Okay, so again, thermodynamics, study of heat and how heat behaves. Absolute zero, the point where there's zero energy left in an object, all the energy's been pulled out. And the zeroth law of thermodynamics, if you're in equilibrium with if two things are in equilibrium with the third, then they're all in equilibrium with each other. So here's why that one matters. The two objects would be like 2 cups of water. And the third object would be a thermometer. You put the thermometer in the first, it's 70 degrees. You take it out, you put the thermometer in the second, it's 70 degrees. The reason that matters is we need to establish that we can use temperature to measure how objects behave. So it's called the zeroth law because we came up with it after the others, but it needs to be true for the others to be true. So that's why it's the zeroth law. Instead of changing the first to the second, anyway, they just made the zeroth law. So the zeroth law just establishes temperature. That's the main thing. All right, here we go. Ready? All right, here's the second part. We'll do the questioning here. Here's the questioning part here. Okay, what's the zeroth law? Everything's in equilibrium. So how hot can something get? There's no limit to the high temperatures, I think is a good one. So there's a limit to the low. There's not a limit to the high. And thermodynamics are study of heat. So again, zeroth law, when all things are in equilibrium with each other. There's no limit to the no upper limit on heat, but there is a lower limit. I should rephrase that. No upper limit to temperature. There is a lower limit to temperature. And again, thermodynamics is trying to understand how heat works. So thermodynamics is understanding the transfer of this energy. How the energy behaves, what it does, that sort of thing. All right, here comes the last part. And this is kind of going into just a little bit more detail on what I said. I'm going to rephrase this everything is in equilibrium thing. But to just talk about this, so the reason there's no upper limit on the heat, there's no upper limit on temperature because you can keep pumping energy into something. You can keep putting energy in and energy in and energy in and energy in and energy in. You just have to keep doing work on it. But you can keep doing that, and it just goes up and up and up and up and up and up and up. To lower temperature, you have to take energy out. And that requires work. So refrigerators do that, right? Refrigerators pull heat out. When the heat should be transferring in, they pull the heat out. Well, it takes more and more and more energy. As you go, you get closer and closer and closer. But it gets harder and harder and harder to do. Think like reaching the speed of light. So you can keep going higher and higher and higher and higher and higher to infinite temperature because you have infinite energy. Well, not quite infinite energy, but you would approach infinity. The temperature approaches absolute zero, but it would require infinite work to pull all the energy out. That's impossible. You can't do infinite work. Therefore, you can never actually reach absolute zero. Now, a couple of years ago, they did reach absolute zero by cheating. So that doesn't count.
How they cheat?
They use quantum mechanics. So quantum mechanics, things can do weird stuff. And apparently one of the weird stuff it can do is have a temperature that's lower than absolute zero. So anyway, so again, it isn't actually, but it was. But it wasn't. But it was. So anyway. So those are your big ideas there with the first law. So first law, with the zeroth law and stuff. So we're just establishing what thermodynamics is and establishing what temperature is, establishing what heat is, its transfer of energy in and out. The three laws are going to expand on that. So they expand on how the energy is transferred and why the energy is transferred and how what becomes of the energy, and we'll get into that next time. So that'll be where we stop today.